Hi, my name is Nurafrina Farzana. This is my lab reflection video for job sheet 1, where we studied the relationship between RMS and peak values for sinusoidal waveforms. So, first of all, let me explain a bit about RMS and peak values. RMS stands for root mean square. It's basically the effective value of changing like AC signal. It tells you how much power the signal can deliver, equivalent to a steady DC signal of the same value. Peak value, on the other hand, is the maximum voltage reached by the waveform during its cycle, either positive or negative. For a pure sine wave, the RMS value is equal to the peak value divided by the square root of 2, or about 0.707 times the peak. So, what is their relationship? The relationship between RMS and the peak value for a sinusoidal waveform is RMS equal to peak value divided by square root of 2 times by peak value. Now, in our lab, I recorded some results using both an oscilloscope and a multimeter. For example, from the oscilloscope, I got a peak value of 1.46 volts when the multimeter showed 1 volt RMS. That makes sense because 1.46 times 0.707 is about 1.03, which is close to 1 volt. We also compare other waveforms like triangular and square. I noticed that the RMS value for the square wave was the highest, about 5.93 volt, because for square waves, the RMS is the same as the peak. For the sine wave, it was 4.24 volt, and for the triangle one, it was lower, around 3.64 volt. One challenge me and my team member Dora had was reading the oscilloscope value accurately, because sometimes the waveform wasn't very stable, but this lab helped me understand how RMS and peak value relate in real signals, not just in theory.